¿Quieres estar a la última en innovación? Visita www.centrodeinnovacionbbva.com.
And in 2012, he joined the Google Enterprise Division as a sales engineer, where he gradually takes responsibility for pre-sales activities for the French and Spanish market. He has notably active in developing the ecosystem partner in coordination with the developing teams. Certainly, we at BBVA and Google are such great friends, and we're also happy to have you here. And then afterwards,
no worries. I'll do the the introduction myself. Shall we do the pitch in Spanish, in English, in both languages at the same time, or?
Well, we have like half and half.
Half and half.
Yeah.
So probably for the sake of everybody, it would be better to do it in English.
In Spanish. So just for you to know that we are having a lot of followers in streaming. Hello, everyone around the world who are now awakening in the USA and in Mexico and in Latin America. So say hello, put your very smile, and welcome.
Hi, everyone. I'm John Lorenzo, and I'm the head of cloud sales here in Spain. I'm looking after Spain and Portugal. Basically, I want to do the introduction of Sebastian and Agnan's presentation, which is going to be all around big data. The reason why we wanted to do this way is basically because, I mean, Google, since the very inception of the company, since these two guys in 1989, I believe 16 years ago, actually started, they encountered some very nice challenges, meaning that what they wanted to do basically was organize the world's information and make it universally accessible and useful. I mean, when you think about that, you go back to 1998 and you try to do technology that we had in that moment. That was virtually impossible. I mean, there was no compute power enough, there was no networking, no bandwidth, no nothing that could actually get them to lead this task. So many of the things that the company had in its mind, even before we actually talked about cloud computing, was actually cloud computing itself. So for the past 16 years, as I said, Google has been building out the world's fastest, most powerful, highest quality cloud infrastructure on the planet. Meaning that the first thing that we had to do is actually we had to start from the very bottom to the very top of the data center when we actually wanted to do this. Why? Because we were looking at a computation matrix. Guys that are pretty familiar with networking will know what I'm talking about. And we went to the guys at the networking companies and saying that we need a computation matrix that can move these X terabytes of data in between data centers and also interconnect these data centers with these bandwidths. And they were like, you guys are nuts. I mean, this cannot be done, not now. So we had to go back, redesign the plans and say, okay, we have little money, we have very little budget at that point in time. How can we do that? So let's define something that will work for us. So in the end, we ended up defining what, in coordination with the universities, was the inception of an SDN, of software-defined networks. By the way, Google nowadays is probably the biggest software-defined network that you can find in the world. Everything is homebrewed, our switches, and then all the control panels are actually running computers. Let's put it that way. The cloud infrastructure that we are proposing or that we are opening to the world is basically the same cloud infrastructure that we are using every day for Google Search, for Gmail, for Drive, for Maps, for Earth, YouTube, you name it. I mean, this is what we use on a daily basis, and this is the infrastructure that we opened in order to other companies use it. Oops. Okay. And the other thing that's really interesting about our network is that we try to be as respectful with the environment as we can. We build our data centers the closest that we can to renewable sources of energy, and also to rivers or sources of water, because what we try to do is actually cool down the data centers with water cooling systems, with water pipe cooling systems, meaning that we don't use air conditioning. So our data centers normally tend to run into a higher, let's say, degree of temperature. But on the other hand, what we do is basically trying to be a bit more green and carbon neutral as much as we can. So just imagine the size of a Google data center being carbon neutral. That's good news for the environment, I would say. The other thing that we do in our data centers is that our data centers are all connected by our own fiber cable. That means that we have submarine cables. Oh, no, sorry. We have submarine cables connecting the west coast of the US with Japan. There's some submarine cable as well in the China Sea. And there's also submarine cable, as far as I remember, that's connecting Boca Raton in Florida with Recife and Fortaleza in Brazil. So, but basically, all our data centers are connected by our own fiber. That means which means that we have the bandwidth that we need and the speed that we need in order to connect information in between data centers. One thing that's really key when we talk about cloud, especially public cloud and especially Google, is security. I mean, everybody is really concerned about public cloud and security. Just to let you know that we take it very seriously and that we do a lot in encryption, and we have probably all the certifications that we can have, like HIPAA or PCI. We are complying with most of the certifications that you can actually have or you can find in the market. The other thing about security, about Google security in the data centers, is that not even being a Googler, you can actually access any data center at all. I mean, you can pass your badge, you will never get in. You need special permissions, and only the guys that work on the data centers can actually get into the data centers. It's something that we take really seriously. So, as I was saying, I mean, developing at the scale that we want to develop means that we encounter really complex challenges in terms of the speed that we have to serve the searches. Nobody will be waiting for a search, not even a second. We are not patient enough. Back in the old days, when we had other type of connections, maybe we could wait for 8-10 seconds for a search or for something that we wanted to load. We don't wait a second nowadays. So we need speed, we need availability, and we need locality with massive amounts of data. Going to the platform, which is where probably Sebastian will be taking over in a second, just to let you know what do we do here. I mean, here we are basically talking about infrastructure as a service and platform as a service. Basically, we do compute engine where you can spin certain things that we will be looking at only, let's say, the networking up to the operating system, and from there up to the applications that you want to run. It will be your responsibility, whatever you want to run in that part of the data center. Container engine. I mean, if you are familiar with container technologies, you will know that this is getting more and more standard nowadays. That the container provider that's more used, or let's say the most used in the world nowadays, is Docker. We are collaborating with Docker, or we are getting compatible with Docker, so as any other cloud provider is nowadays. And App Engine will be much more a platform as a service, which is a little bit more restrictive in terms of languages, but it's much more faster to deploy, which is, I think, that companies like mobile developing companies or gaming companies would like to use because of the speed or time to market. In terms of storage, I mean, there's nothing very spectacular. What we do here is either we do databases that are fully managed in the cloud, which will be Cloud SQL. We do blob storage. We do Cloud Data Store. And in terms of analysis, Cloud Data Flow, which is something that we just launched in the market, Cloud PubSub, and BigQuery, which is where Sebastian will be for sure talking quite in depth about it. Just to give you a few examples. Sorry, you get in, and then I'll give the examples. Is that okay?
Thank you.
You're welcome.
So just before, let me introduce some numbers, just to explain that at Google we consider that we are a big data company. In 1 minute at Google, it's more than 100 hours of new video on YouTube. It's more than 3 million searches on the search engine, and it's more 1,000 new devices activated per minute. So it's why we have this infrastructure. So we have our network, we have our servers, we have our data centers, but it's not enough to manage all this data and all this increase of data. Imagine that the Google was created in when? 1998. And the beginning for the big data for us was with Google File System in 2002. In 2002, what was the challenge? The challenge was to have only one index for the search engine distributed around the world in all data centers. It was not possible with many data centers and a network. It was not possible. So we invented GFS, Global File System, to do that. And we invented MapReduce in 2004. What is GFS and MapReduce? It was foundations of Hadoop. So we invented a lot of technology to manage all videos, all the search engine, all Android activations. And in 2008, we published a paper named Dremel. What is Dremel? Dremel it's basically a big database to store all information and query all information very performantly. And the name of Dremel is now BigQuery. Just to explain what is the origin of Dremel. We have a lot of servers, we have a lot of networks, a lot of search engine, a lot of advertising on the search engine. The challenge was how to query all this information in some seconds. With a traditional database, it's possible to store data, but the query takes a long time, and the query takes longer and longer time with the volume. So big data for us, we propose a platform. We propose infrastructure and technology. It's a complete platform to manage a big data. And our vision is to propose a big data as a service. What is the challenge of a big data project is to make easy to manage cost and performance. It's why all pieces, storage, data flow, BigQuery, are there to manage one challenge of the big data. We can address everything, but we have a platform, but it's a modular platform. It's not a complete platform, and our vision is not to replace your Hadoop cluster, your storage. We need to connect to your infrastructure. It's why it's possible to deploy Spark, Hadoop, Kafka on our infrastructure. But if you need the new generation of technology to manage big data, it's possible to do that with Google. What is our vision? Our vision is to manage infrastructure. Just an example for BigQuery. You have anything to do. No servers to install. No software to install. It's just a service. You put your data at Google, and after you can query all the data. Everything is managed by Google. It's a service. And it's the same thing for PubSub, storage, and data flow. What is the objective of PubSub? PubSub, it's a bus. It's a pipeline. It's the first step of a big data project, is to capture all information from a public website, from a mobile, from a sensor, from anywhere. So we propose a bus, a pipeline distributed around the world. With nothing to do, you can put a message and get the message in the finality. After you have captured the data, you have to do nothing. So you want to store this information. Store information, it's really easy. You have hard disk, you have a SAN, you have many technologies. But what is the challenge with the storage? Is the cost and the complexity of the infrastructure to store data. With Google Cloud Storage, you can put a file, you can put image, you can put data without anything to do. It's distributed around the world, and you have the same performance in US, in Japan, in Europe. What is interesting with Google is that you can localize your data if you want. If you want, you can localize in Europe, in US, or in Japan. It's complementary with the security. So we capture the data and we store the data. Now we need to transform or to process. It's possible with data flow. With data flow, the concept is to focus on transformation. You code your transformation in Java or in Python, and you put the code at Google. And Google scale automatically the infrastructure, the number of machines needed to do the transformation. It's like the new generation of MapReduce. What we invented, Dataflow, it's because our customer and us had a lot of MapReduce and Hadoop cluster with many nodes. And at the end, it's complex to manage this. It works perfectly, but it's complex. You need skills, you need machines, you need scalability. How to do that? The proposition of Google is to say, okay, focus on your code, infrastructure and scalability, it's our job. Now we can transform the data. What is important with Google is that our customer want to analyze in real time, not only batch. So now with the platform, you can capture and analyze data in real time or in a batch without anything to change. You don't have to use Hadoop for batch and Spark for real time. It's only one technology. And the finality is to analyze this data. And this is the job of BigQuery. Maybe you can explain Execuse?
No. Yes. Yeah, I'm back. So Execuse is a customer that we have in France that actually does RTD. Basically, they are a data management platform. What they do is basically they collect cookies from all their customers and analyze all those cookies to understand the behavior of the customers that these companies have in order to know exactly what they want so they can add value on top of the adverts that are going to be displayed through that platform. That's basically what they do. So Execuse is running nowadays a 1,000 instances Hadoop cluster. And well, they are able to manage a significant amount of data that they were not able to manage when they were using their own infrastructure on premises. Because basically the amount of data grew exponentially and they were not able to cope with what they had. I mean, the cost of infrastructure every time they got a new customer was preventing them to get new customers, whereas now they can scale in a way that's really cost efficient. They can get new customers in, and the platform will scale as much as they need in a cost that will allow them to get more people into the platform. That's basically it. I believe that we have a second example here. Yeah, DNA it's a Japanese company that basically what has is they have agreements with loads of gaming companies, and they get data as crazy every day in order to analyze. When I mean as crazy, I mean that they get like 50 megas per minute, and they end the day with, is it with 50 gigas or something like that every day of data that's just analyzing how many active players do these companies have, these games have, in order to understand what are the most popular games and what should they be doing in order to make these games more popular, or what are the type of games that people like most, so they can actually somehow let companies know what do they actually have to create in order to basically get more customers and get more money in. We had a video, but it's really long, so we thought there was no purpose on showing you the video where they explain exactly what the whole situation. But basically, what they are using is BigQuery in order to analyze all these vast amounts of data in real time every day. They get a process every night, so they can tell these companies what should they be doing in order to improve, or how many people is dropping the game, so they can know how can they improve and how can they keep people playing in the games. And they were making like, I believe, like 5 billion in Japan, or something like that. $5 billion in Japan, and something like $1 million in the rest of the world, because Japanese people love gaming much more than we, anyway. But I mean, a huge successful company that's only based in analyzing data and bringing these companies the value of knowing what are the best games, the best-selling games, and how to keep people playing those games.
So I propose to you to show some demo, because big data, sometimes it's more a concept. And since the beginning, I say it's simple, it's less expensive, I can't say it's for you, and it's performant. So I propose to show you. So I don't know if you know what is it, Google Cloud Platform, but I know it's there. Okay. So BigQuery. I said at the beginning it's a big database managed by Google. So you have only one thing to do. It's to put your data and query. So on the left, I have some data set. Data set is like a schema, or I have many tables in the schema, and you put your data. And query composer is just to test. And in my sample, I have a query on a genomics data set. Why genomics? Because in genomics, we have a huge volume of data. And I can execute the query. Sorry. It's not fair to use the cache. And you can see that in 6.2 seconds, I can analyze 2.9 terabytes of data without install any database, any servers, any Linux, any Windows. Just put my data. It's approximately 30 minutes, 1 hour maximum to put all this data in the database. And after I can query this kind, build this kind of queries on the top. To do the same thing, you need a complex architecture with a traditional database. What is interesting with BigQuery is that it's the same performance for 220 or 200 petabytes because performance and scalability are managed by Google. So it's simple and it's performant. Just another use case. Interesting because we have many customers interesting by the e-reputation. And they want to analyze social networks, Twitter, Facebook, and to collect information. So since the beginning of the project, they need to create infrastructure, a database to store all this data before analyzing them. This quick demo captures all information coming from Twitter on a specific theme. It's on plane and flights, and we can analyze very huge number of data. And we can propose, for example, travel, a timeline of the tag travel in Twitter. So it's a very quick demo, but just to show you that it's possible to manage this, it's really easy to connect Twitter to BigQuery and to analyze maybe BBVA, innovation, some tags, and manage this huge amount of data without install any servers, any database. John? No? Another use case, interesting use case, Motorola. We talk about Internet of Things. We have a lot of buzz on Internet of Things. I see a car there, maybe it's a connected car, I don't know. But with connected equipment, objects, we have a lot of information to collect, to capture, to store, and to analyze. BigQuery is perfect for that. So we have many customers in RTB, in digital company, or traditional company that are interesting to, in real time, collect all this information and store and analyze them. BigQuery is perfect because it's possible to stream in real time data directly in a BigQuery storage and analyze them. And I have a quick demo just to show you. I have on my laptop a mobile application, a native mobile application that sends every 10 seconds a log, some information, to BigQuery. And I build a basic dashboard that collects and aggregates all this information. And just to show you performance, it takes some seconds to display in real time information coming from my mobile. So it's a typical use case of the platform. Analyze in real time all information coming from device, games, glasses, cars, sensors, I don't know. And the last demonstration. I talk about a platform. We have to understand that we propose only the platform to store and analyze. We don't have dashboarding technology, but it's SQL technology. So you can use Cognos, Beam, Tableau, ClickTech, any kind of technology to use the platform. Build your own dashboard. In this sample, I'm using Beam because it's a French company, sorry. And just to show you performance, I can display in maybe 1, 2, 3 seconds a dashboard based on 1 billion of records. To do the same thing with a data warehouse, for example, it's complex, it takes time. With BigQuery and the platform, you load your data and you query. And another use case is just to see you some perspective. We collected all information coming from the taxi in 2013 from in New York City. So it's approximately 170 million of data. We put all this data in a data set in BigQuery, and we build with Google Maps a visual dashboard, but it's a map dashboard, and in real time, it query all information. So it's simple, it's performant, and it's not expensive, but it's done. A complete platform. So just to summarize, a Google Cloud Platform is a complete platform to manage a big data project as a service, completely managed by Google, to capture all information, to store all information, and analyze. Easy, inexpensive, and fast. And you can use, if you want, your own technology. And you can mix Google technology with open source or other technology as Hadoop, Spark, Kafka, I don't know. You have any questions?
We were really more than in time. I mean, you are not French and I'm not Spanish. I mean, we are nearly British, I'd say, because of the timekeeping. So we have like 10 minutes for questions if you're interested in knowing anything else about what we do in BigQuery or any other thing that you would like to know around it. So who's going to be shooting first? All right, there's always one. Hi.
You have said that you can use this product with other products. Is needed any kind of plugins or driver or something like this, or how to use all these tools together?
Like you mean how can you BigQuery through pops up with, I don't know, with
all our products are accessible by API or connectors. So if you want to connect PubSub, storage, BigQuery, it's native, it's really easy. But it's possible with a third tier, with another software, with your own software, with a Java application or Python application, because it's a REST API. So you can execute a query and you can get results by the API. You have another command line tool if you want. You have command like BigQuery, create table. It's possible to do that. And you have the user interface. And you can choose the best access method for you to do the job. And what is interesting, it's REST, so it's completely standard. If you want to use BigQuery to analyze and integrate in a .NET application, it's possible. You can do it. You just have a connection between your application and Google Cloud. But it's internet, HTTP, REST, it's standard.
You will also be able to connect with your own data warehouse. I mean, like if you have any data warehouse technology at home, that can be also connected, and that data can be ingested as well into big data.
We have many customers that have a data warehouse, Cognos, SAP, Oracle, and it works perfectly. But they want to mix this information with digital information, coming from Google Analytics Premium, coming from another system or mobile. It's not easy to mix this kind of information in a repository. But with BigQuery, it's possible to do it. So you extract your data coming from your data warehouse, and you mix with logs coming from your public website or your, and you can analyze deeper the profile of the customer, for example, without any change in your traditional data warehouse. Yeah?
So you showed us BigQuery analyzing 400 billion records in about 6 seconds. How long would it take to get a single record out?
The same time he could.
Right. So I'm just trying to understand the paradigm. So
no, to be honest, if you have only 4 records to store and you want to analyze them, I'm not sure that BigQuery is the best tool for that.
I'm saying if I got 400 billion records, but I just want a particular one.
The secret sauce is we are able to parallelize.
Yeah.
So it's another paradigm. So it works perfectly, and it's why we have the same performance and the same response time for terabytes and petabytes, but one record too.
So it's a full scan.
Mm-hmm.
Which gets me to sort of, I was trained as a statistician, and it strikes me as odd to store 400 billion records and then present, it's a lot of work to store and query 400 billion records, and then to present a roll-up saying 55% of them are blue, when you could sample 40,000 of them and get a answer. So why have we stopped sampling? Why have data scientists forgotten the statistics?
I think it's complementary, to be honest. We don't stop to sample.
Sorry about laughing, but I like very much statistics. So maybe I jump in and I can help you a little bit in this. I mean, when you sample, probably you are sampling over a certain sets of data. Just imagine that you are not only analyzing one particular set of data, but you are analyzing, in this case, as he said, cookies or log files. You are getting into any sort of web analytics. You are getting information from a data warehouse. I mean, you have so many different sources of information that I'm not sure if you actually sample data from each of the different sources that you are going to be analyzing, you will get to the same results. What I mean is that, interestingly enough, I don't know if you know flu trends. That's one of the first, maybe you can show flu trends. Let's do something live. That's always nice to do, because it can break and nobody will you know, nobody will take it like something bad or nasty because it was done, you know, real time, really real time. Like, I'm not sure if you're familiar with these, but probably you've seen these. I'm just going to the Spanish page anyway. You can go anywhere. So this is basically analyzing Google queries, or Google search, sorry, on people searching on flu. The idea is that, what I was trying to explain here with this is that actually we got wrong results. And you know why? Because we were analyzing only the idea of people searching for flu when they are actually ill, or when they feel that they are ill. But we were not taking into consideration that people might have kids or may have elderly people who they care for, and they were looking for information for those other people. So in the end, the flu, let's say, outbreak was not as bad as expected, because we were considering that the peaks were going to be produced due to those searches, but those searches were not all related to actual flu cases, but also to other sets of data that we were not analyzing. So that is the reason why probably sampling is good when you are analyzing, let's say, data only one way. But when you have to analyze the whole picture, can lead you to, or can mislead you, as it did to us.
Can I do a table join in BigQuery?
You can do a table join at BigQuery.
400 million records and 400 million records?
Yes, but we have a specific mechanism about joins. But yes, but you just have to understand that for me it's complementary. To make a sample from data coming from BigQuery, for example, and for joins, it's the same thing. We have to think differently. If you want exactly the same mechanism in a query than in a traditional classical relational database, no, it's not the same product. But you can join tables, yes. But you can't, it's possible to do that. Possible to join maybe 20 tables. But I'm not sure. I'm sure that the performance will not be as good as a classical database. You have to denormalize data and to understand the model behind to have the power of the platform. And it's why we have a customer that use traditional database with BigQuery or Hadoop MapReduce with BigQuery and mix all technology depending of the requirements. And I'm not sure that I don't say that BigQuery is a unique technology that can do everything. No, it's not true.
No, the idea is that you actually can enrich the results that you can get through the usage of different technologies. And in the case of Internet of Things, we are getting so much information that is really, probably there's no other way that you can analyze data in a efficient and efficient manner. So that probably the reason why big data is going to be probably a buzzword for quite a number of years from now. You can actually, this page is a public web page. I mean, if you are kind of interested or curious about what we do there, it's google.org/flu-trends, I believe. And it analyzes the data based on the searches made on Google for flu worldwide.
Maybe just to finish the presentation, it's easy for you to test the technology. Everything, you can test everything. Just create an account. You have a free trial option, and you can use test BigQuery, Dataflow, PubSub, all components we discussed today.
And without any further ado, we are right on time, 4:00. So,
thank you very much.
Thanks very much.
Si quieres estar a la última en innovación y emprendimiento, visita www.centrodeinnovacionbbva.com.